Hello, friends. Welcome back to another lecture from the platform of Learning with Maths, Learn with Classes. Today, we're going to be talking about a very interesting aspect of maths, and that is geometry. Geometry is a very fascinating branch of maths, and it deals with the study of shapes, sizes, positions, and dimensions of different objects. It involves an understanding of spatial concepts of lines and using lines, angles, and various shapes in being able to understand different aspects of the world at large. The word geometry itself comes from two words. It's a combination of two Greek words. One is geo and one is metron. Geo itself means earth and metron means measurement. So using concepts of geometry, we're actually going to be learning how to measure each and every aspect of the earth, whether it be areas, whether it be perimeters, whether it be volumes, and we're going to be able to do everything with relation to measurement of the earth. We're going to be starting with a very interesting aspect of geometry, and that is going to be
Triangles. You
triangles.
already know what triangles are. A triangle is a shape which is a closed shape made up of three sides. I start with one vertex or one corner, get a side, a second side, and a third side to come back to the same place. So it has three sides, three angles. And when I say three sides and three angles, the total six elements then form the six elements of a triangle. In your earlier classes, you've already known that the sum of the interior angles of a triangle is 180 degrees. Today, we are going to use that concept and learn something more about the triangle, the exterior angle property. So, we're going to be starting with the exterior angle property just now.
Here is a diagram of a triangle ABC, and you can see that your side AC has been extended, and when it has been extended to, let's say, point D, you get an angle by the ray AD and AB, which has already been colored for you in orange, which again I am showing to you. This particular angle is known as the exterior angle of the triangle at the vertex A. So, as the definition goes, if one side of a triangle, say BC, and I've taken the base, that's BC, which is at the base, is produced to form ray CD, then the angle formed by the ray CD, this ray CD is this one here, and the already existing side AC, which I'm showing now here, is called an exterior angle and it is at the vertex C. So here angle 4, which has been marked in mauve color, is the exterior angle at point C, right? Similarly, it's not just one exterior angle you can have. You've already seen one angle. At vertex A, you can see exterior angle 5. And at vertex B, you can actually see exterior angle 6. Is that okay? I'm going to call this as exterior angle 6. Now, once we have understood how an exterior angle is formed, we shall move ahead to understand how it is related to the interior angles of a triangle. Now, the interior angles, if you can see, are angle 1, angle 2, and angle 3. Interior angles are the ones which are inside the triangle, so they are formed within the triangle, within the two sides of a triangle. So, this is angle 1, angle 2, and angle 3. Now, what are the angles opposite to angle 4? I have this one here, which is angle 4. If I look at it now, opposite to angle 4, I will be having angle 1 and I will be having angle 2. So I am going to try and establish a relationship between the exterior angle at point C and the interior opposite angles, which are angle 1 and angle 2. Now, we've already just spoken about this, that the angle sum property of a triangle says that the sum of the interior angles, which here in this case are angle 1, angle 2, let me just increase the width of this. So, angle 1 angle 2, and angle 3. Together, the sum of these three angles is going to be 180. But from your linear pair property, what do you know? Angle 4 and angle 3 together, they also form 180. So there are two things which are equal to 180. On the one hand, you have 1, 2, and 3 equal to 180. And on the other hand, you have 4 and 3 equal to 180. That being so, equal things are equal to each other. So I'll have 1 plus 2 plus 3 is equal to 4 plus 3. That having been said, from my equations which are labeled at 1 and at 2, 1 plus 2 plus 3 is equal to 4 plus 3. And what do I get? The 3 and 3 cancel from each side. And what do I get? I get angle 1 plus angle 2 is equal to angle 4. Let's just go back to the figure and see what was angle 1, what was angle 2, and what was angle 4. Angle 4 is the exterior angle at point C, and 1 and 2 are the opposite interior angles. So it is a very important property of exterior angles that an exterior angle at any given vertex is equal to the sum of the opposite interior angles. Have you got it? So angle 1 plus 2 is going to be equal to angle 4. Similarly, I have an exterior angle at point A. I've labeled it as 5. So 5 is going to be the sum of the opposite angles which are now appearing at the bottom, which are 2 and 3. And so 5 is going to be equal to 2 plus 3. Whatever is the measure of angle 5, it is going to be equal to the sum of the measures of angle 2 and angle 3. Similarly, I have angle 6, which is the exterior angle at point B, equal to the exterior angles, the sum of the exterior angles at 1 and 3. Is that okay? So any given exterior angle is going to be the sum of the exterior angles, interior opposite angles. But then there's a very, very tricky situation here. Sometimes there are some children who sometimes get confused as to what is the exterior angle. Please look at diagram 1, which I am now going to be focusing on. Angle 1, in diagram 1, you can see the angle which has been shaded in green. That is an exterior angle. Why? Because it is formed with the extended side and an already existing side. Right? Now let's look at the figure 2. This angle, which has been marked as green, is formed by one extended side because this is the one which I have extended here, and this also is an extended side. So if I have two extended sides and the angle which I'm talking, which is being made between the two extended sides, that is not going to be an exterior angle. So here in this particular diagram, the green shaded angle is not an exterior angle. So this one is exterior. This one is not exterior. Is that okay? Okay. Now let's just focus on the third diagram. Again, look at angle 3. Angle 3 has been made with the extended side and one of the sides. So it is definitely an exterior angle. And as we've just learned, angle 3, the exterior angle, is going to be equal to the opposite interior angles, which are 1 and 2. They've all been marked in green for your understanding. 3 is going to be equal to the sum of 1 and 2. Let's have a look at angle 4 then. Angle 4 again is made by this extended side and this already existing side. So again, it is an exterior angle. Also, angle 4 is going to be again equal to the opposite interior angles. What are the opposite interior angles in this case? The opposite interior angles are nothing but 1 and 2. So I have angle 4 also equal to 1 plus 2. Angle 3 also equal to 1 plus 2. You've also learned about vertically opposite angles. Do you also understand that angle 4 and angle 3 are vertically opposite angles and so they need to be equal? So we have that at any given vertex, the two exterior angles can be formed, and both these two exterior angles are going to be the same in measure. Is that okay? They're going to be equal in measure. Moving forward, three vertices A, B, and C. And I have three exterior angles at the three different vertices, right? I am picking up angle 4 at vertex C, angle 5 at vertex A, and angle 6 at vertex B. We just learned they are equal to the sum of the opposite interior angles. So what is 5 here going to be? 5 is going to be the sum of 2 and 3, which I have put here. 4 then is going to be the sum of opposite ones there. So that's 1 and 2. So that's 1 and 2, which I have put here. And then I have 6, which is going to be equal to 6 is the exterior angle at B. It's going to be equal to the opposite ones. That's 1 and 3. So I've got 5 equal to 2 plus 3, 6 equal to 1 plus 3, and 4 equal to 1 plus 2. Let's combine these three equations. On the left, what will I have? 4, 5, and 6, which is the sum of the three exterior angles at B, A, and C. And on the right, what do I have? I have to add up angle 2 plus 3, 1 plus 3, 1 plus 2. How many times has 2 come? Let's just have a look at that, please. I'm just going to increase the darkness and I'm going to, yeah. So angle 2 has come in 2 times. Angle 3 has come in 2 times. And angle 1 has also come in 2 times. So if I have to combine the three equations, what am I going to get? The sum of the interior angles 4, 5, and 6 is going to be 2 times angle 1 plus 2 plus 3. But what was angle 1 plus 2 plus 3? Let's have a look at the diagram again. 1 plus 2 plus 3 is the sum of the interior angles. And what is sum of the interior angles? We just know that to be 180 degrees. So when I say 4 plus 5 plus 6, it's going to be 2 times 180, which is 360 degrees. What is 360 degrees? 4 right angles. So sum of the exterior angles of a triangle is, I can either call it as 4 right angles or I can say it is equal to 360 degrees. Is that okay? With this, we are going to move slightly ahead and look at a few questions which are based on the exterior angle property, right? I have this question in which there is a triangle ABC. If I show you, this is A, B, and C. BC and CA are produced. Now, BC is produced to D, CA is produced to Q, and BA is produced to P, right? Respectively. And then after we produce them, what do we have? We've been given the measures of a few of these angles. The angle at A has been given the vertically opposite angle. Can I call it the exterior angle? I can't call it the exterior angle because this is the one which is made between the two extended sides. So that is given to you as 35 degrees. Angle 4, which is an exterior angle, because it is made with an extended side and one of the already existing sides. So that is an exterior angle, angle 4, and that's given as 100. There is no other measure given. What I need to do is to find out all the angles of triangle ABC. Now, in a geometry question, there is a proper method of attempting. You're supposed to be writing what is to be found out. You're supposed to be drawing the diagrams, and then you are going to be writing this given here. And you've already got the whatever is given here. I've written on the top, and then I'm going to be writing the proof or the solution. So I'm writing the solution here. Now let's look at QAP. QAP, I'm going to change color here so that it is different. QAP is this angle on the top. Do you all agree it is going to be equal to the vertically opposite angle, which is angle 1? And so if QAP is 35, the interior angle at point A is also going to be 35. Yes or no? Yes, it is going to be 35. That we will keep parked on one side for the time being. Now, we also can say that the exterior angle at point C, which is 100, is going to be a sum of angle 1 and angle 2. Why? Because it is the sum of the interior opposite angles. So angle 4 is going to be equal to angle 1. So let me just write this down. Angle 1 BAC we've just found out to be 35 degrees. Now in triangle ABC, I've just told you angle 4 is nothing but angle 1 plus 2, and that's the exterior angle property. What is angle 1? We've just found out that is 35 degrees, plus angle 2 is unknown to us, and angle 4 is given as 100 degrees to us. So from here, if I transpose 35 to the right, I'm going to get angle 2 is equal to 100 minus 35, which comes out to be 65 degrees, right? So I've been able to find out the exterior angle at point A has come out to be interior angle, sorry, at point A has come out to be 35. Interior angle at point B has come out to be 65. Now only one of the angles is left, and that is my angle at point C. So I can either use my angle sum property or I can use the linear pair property. Can you see the 4 and the 3 here? They together form a linear pair. And so if 4 is 100, what is 3 going to be? Let's just see. 3 plus 4 is 180. So angle 4 is already known as 80 to you. So angle 3 then is going to be, it's going to be 100 minus what we've just found, 180 minus 100, which then comes out to be 80 degrees, right? Therefore, the three angles which we just found out, the first one was 35 degrees, the next one 65 degrees, and the final one 80 degrees. So once you found out all the answers, you are supposed to be writing down the answer statement as well. Is that okay? Let's have a look at question number 2. Another exterior angle property question. You can make out, how can you make out it's an exterior angle property question? Because you can see some exterior angles have been marked out. Now the side BC is extended towards the left also, it's extended towards the right also. When it's extended towards the left, you get point D. When it's extended towards the right, you get point E. So what have been marked out for you are angle 1, 2, and 3 as the interior angles. 4 is the exterior angle at point B. 5 is the exterior angle at point C. What do you need to prove? That the sum of the exterior angles so formed is greater than angle A by 2 right angles. Now each right angle is 90 degrees. So let's start. As I told you, we have to write down what needs to be found out, draw the diagram, then proceed with the proof. Angle 4 here should be equal to angle 1 and angle 3 by the exterior angle property. Similarly, angle 5 here should be equal to angle 1 and angle 2. So this is what has just been written for you, that 4 is equal to 1 plus 3 and 5 is equal to 1 plus 2. Now, if I move ahead with that, can I see that I needed to prove that the sum of the exterior angles so formed, so 4 plus 5 is equal to angle 1 plus 2 plus 3 plus 1. What is 1 plus 2 plus 3? 1 plus 2 plus 3 is nothing but 180 degrees. 180 degrees is nothing but two right angles. And what is angle 1? Angle 1 is nothing but A. So the sum of the exterior angles, you have been able to say that it is 180 degrees more than angle 1, or it is two right angles more than angle A. Right? I just wanted to be able to do more sums, so I am going to be leaving them with hints, not going on to solve the entire question. Now, here there is another diagram-based question in which you need to find out your x, which is at this point. Okay, how do you do that? You can see I have used some legends. First, I'll use the blue marking one. I have been given that the angle FE, let's just call this, let me call it G. FEG has been given to you as 120 degrees, right? I'll use a darker color. FEG has been given as 120. Going that by that, use the blue arrow to see what is going to be DEB. This angle here, the linear pair property should give you that this is 180 minus 120. So this is going to give you a 60 degrees, right? Now, after that, I've finished the blue legend. Now let's come to the green legend. This angle here and this angle here are the interior opposite angles to this exterior angle, which I marked as a green. And so this 60 and 30 together is going to give me a 90 degree as your angle DCDE. So this angle here is going to become 90 degrees. Did you understand how? Again, I'll say 60 degrees and 30 degrees, the ones which have been circled, the green ones which have been circled in red, together are going to be the interior opposite angles. And when they are added, you're going to get the exterior angle on the other side. And that exterior angle is nothing but 90 degrees on adding them up. Now, let's move on. So I've been able to finish the blue. I've been able to finish the green. Now let's look at the final pinks. If I look at this here, this 60 and this 90 are the, for this triangle DCF, for the triangle DCF, this and this are the interior angles for this particular point, which is your angle X. Now, therefore, angle X is going to be the sum of the two interior angles which have been marked as pink, which are 90 plus 60. So, angle X is going to be nothing but 150. So, step by step, you shall be able to reach in a very, very simplified way. You do not need to get bogged down. Let's have a look at another question. Here again, you've been given certain things and you need to find out your X. There is a triangle which is ABC, which is right angled at A. You can see that it's a right angle at A, right? Okay. You have another triangle which is BED, which is right angled at E. The only other information given to you is that the angle AFE here is 130 degrees. All this information given, you need to find out what is X. Okay. Now, knowing this much, can I say that the two blue dots, that's angle E here and angle C here, should be equal to the exterior angle at point F for triangle FEC? That angle on the top is the exterior angle and below the interior angles are angle E and angle C. If this one here is 90, what do you think this one is going to be? Obviously, on both sides, I'm going to get a 90. So this is also 90. This here is given as 30. So 90 plus C is 130. And so what do you get your C to be? Angle C is going to be nothing but 130 minus 90, which is 40. So you've got this and you're done with step one. You've got 40. Now you need to find out X. Look at this. I have marked three particular angles with a yellow highlighter. So angle C, you've got it as 40. This here is already given to you as 90. Can I use another color ink so that it is clearer to you? So this here is given as 40. This here is given as 90. From this, you need to find out the third angle of triangle ABC. So in triangle ABC, what will you have? Angle X plus interior angle at A plus angle C is 180. So angle X is going to be nothing but 180 minus C and A. What is C? C you've already found out to be 40. A given to you as 90. So you have your 180 minus 90 and 90 and 40, which is together 130. So you're going to get this as 50 degrees. Is that okay? So your answers are very, very readily, easily available. You just need to keep your properties in mind. When you're doing triangles, you should also be having all your properties of lines and angles very, very clearly established in your mind. You will see that in quite a few sums, we've used the vertically opposite angle triangle as well, property as well. So this is as far as the exterior angle property is concerned. We will next take up another interesting property, which is the Pythagoras property, in the next lecture. In the meantime, if you have any questions, you want to get back in touch with me, you know where to meet me, you know how you can contact me. My numbers at LearnMate classes are 986755061. It's also up on the board. You can easily get in touch with me. Thank you. Have a nice day.